All right, week 1, lesson 1. I didn't title that. Sorry. Getting used to distance learning. Today's lesson's actually probably pretty short, won't take too long, but I want to go through this idea of what this distance learning might look like for our class and show you a video, have you guys actually look at some stuff that you can use as an online tool, and then actually submit an assignment for me. So, getting used to distance learning. First thing that I want to remind you guys is that if you don't have your graphing calculator at home, Desmos is going to be a very close personal friend to you guys. You can use Desmos online. You can use it on your phone. You can use it as an app. If you remember that I've got the app on the iPad, it allows you to graph equations and not solve things for y, so we could graph circles, etc. So, thinking about that, Desmos is going to be part of that distance learning piece, and for today's lesson, all I want to actually do is walk you through and review linear, quadratic, exponential, and circle functions. So, taking a look at this first one, this is an example of your linear function, straight line. So, what are important pieces of information that we get in linear functions? If you said slope, you are correct. If you said y-intercept, you are correct. If you said x-intercepts, you are also correct. All of those things are important parts of the linear equations. So on Desmos, if you could do me a favor, open your Desmos and go ahead and graph these 3 equations. My thought is when you start to graph them, you'll start to recognize that all 3 equations are the same thing. This first one is in your slope-intercept form. The second one is in your point-slope form. And the third one is in your standard form. Now, all 3 of them give you unique pieces of information. For example, what do we get from slope-intercept? Yes, you're right, slope and y-intercept. What do we get from, so the slope in the first one is 2/3. The y-intercept is 0, 2. Now, it makes sense, though, that in the second equation, because it's the same line, being that it's a point slope form, that it also has a slope of 2/3. And this time, though, we don't have the y-intercept. We have a point on the line. We have the 0.34. The standard form allows us to find both the x-intercepts and the y-intercepts very, very quickly. Remember, you can use that cover-up method. So cover up your 3y. Negative 2x equals 6. Then cover up your 2x, you end up with 3y is equal to 6. In both instances, what you end up finding is that x equals -3 and y is equal to 2. And if we look at that, we can see those y-intercept and the x-intercept on that. So again, refresher on linear. Quadratic. This is another one that we did a lot with. So this is your example of your quadratic function. I gave you all 3 forms of the equation right next to us. The first form is your factored form. The second form is your vertex form. And the third form is your standard form. Now, we've reviewed these, but factor form gives you x-intercepts. Vertex form gives you the vertex, and standard form gives you the y-intercept. So you can see the y-intercept is there. There's one of your x-intercepts. There's the other x-intercept, and your vertex. So just take a couple of minutes and play around with Desmos. Make sure you can enter these equations into Desmos and you can actually create the same graph that I have. So the other thing that you learned in Algebra 1, and I don't think we've done a lot of review of these in this semester, but is that exponential function. This is what you hear if you're listening to the news about the coronavirus. This is what you hear doctors and pundits talking about, because that's what we're saying that this coronavirus is doing. The number of people infected is growing exponentially. So the pieces of information that are really important on this one is this 3, that's your y-intercept, and this 2, which is your rate of change. Now, what's the difference between linear rate of change and exponential rate of change? Is this rate of change is multiplicative. It is based on multiplication. Still can't spell. So this one's based on multiplication, so we have exponential growth going on here. So again, just take a couple of minutes in Desmos and make sure we can enter those in, and we can actually look what they, see what they look like. Obviously, you are correct. This one is our circle. Now, I only gave you the one form, and that's the form that is written right here. And this is so it is already written in center and radius. Now, these two things give you the center. They give you your h and your k. So that would be 1, -2. They are opposite because they are inside. And this value gives you your r value. Now, the big mistake that y'all keep making is that you'll tell me that r is 81. You're going the wrong direction. This value in the equation is r squared. So in order to undo r squared, we have to take the square root of 9, and the square root of 9 is 3. Hence, the distance here is 3. There is my center, and there are 4 points on my circle. So that's it for today's lesson. Go ahead and open up week 1, assignment 1, and all it's going to ask you to do is to graph a couple of Desmos functions and to scan it or take a picture of Desmos and upload it into the Google form. Obviously, if Google Forms ends up not working, I will figure out another way for you guys to submit your work. I'm going to give it a try. We'll see if it works. And I will talk with you more when we start talking about lesson 2.